Hi, I'm Dr. Matt Fry, and I'm an entomologist with the New York State Integrated Pest Management Program at Cornell University. Our program helps people develop sustainable methods to manage pests in ways that minimize environmental, health, and economic risks of the pests and the methods used to manage them. This presentation discusses a research article published in 2021 in the Journal of Stored Products Research entitled Assessment of Factors Influencing Visitation to Rodent Management Devices at Food Distribution Centers. In this paper, we examine the current paradigm of interval trap placement for rodent management at food handling facilities. The use of standard spacing between rodent management devices was developed in the 1940s. And is based on estimates of mouse and rat foraging ranges. The thought process in creating the program was something like this. House mice are known to travel between 15 and 30 feet when foraging. By placing devices at 20-foot intervals along interior perimeter walls, foraging rodents will never be more than 20 feet from a device at any time, creating a protective barrier. The same philosophy was applied to exterior bait stations that are spaced further apart to count for rat foraging behavior. This led to the development of the 3 lines of defense approach to rodent management at food facilities. Without testing or evaluation to determine if this approach effectively protects facilities from rodents, it was adopted by third-party auditing agencies and used to develop in-house management programs. For the past 80 or so years, guidelines have remained relatively unchanged, despite advances in our understanding of rodent biology, behavior, and management. And where guidelines have changed to provide flexibility in device placement, interval spacing of devices remains the norm due to customer expectations, existing auditing guidelines, or a client's outdated in-house standard operating procedures. So the question remains, does interval device spacing provide the best protection against foraging rodents? To evaluate this question scientifically, we worked at 7 food distribution centers in the New York metropolitan area and 5 near Toronto, Canada. Sites ranged in size from 8,500 to 198,000 square feet, and all had a history of rodent activity. A list of characteristics was used to describe the area within 5 feet of each device, including 76 characteristics for interior multi-catch traps and 27 for exterior bait stations. Characteristics represented conditions ecologically attractive to rodents, such as food and water resources, and structural features of a building that can affect rodent movement, including the presence of cover and openings. We compared these traits to trap capture for interior devices and bait consumption for exterior stations over a period of 10 to 69 months, depending on data availability from each site. Interior devices were checked monthly at 12 sites for a combined total of 636 months, representing 33,236 observations on traps. Across all years and all sites, a total of 1,491 mice were trapped. The number of mice caught in a trap at one time ranged from 1 to 8, but 84.6% of captures were a single mouse. Most devices trapped mice only one time per year, but some devices caught mice on multiple occasions. The percentage of devices that caught mice in a facility ranged from 13.3 to 91.7%, with an average of 45.2%. This means, on average, less than half of the traps in a facility actually captured mice each year. The percentage of traps with 2 or more captures ranged from 0 to 83.3%, with an average of 29.7%. Several ecological and structural characteristics near traps influenced whether that device would catch mice. Specifically, increased monthly rodent capture was associated with interior traps placed in a corner, shadowed during the day, on the south or west side perimeter wall, near a rodent-proof single door, and near a poured concrete wall. Some of these findings meet with predictions about rodent behavior based on their biology. For example, corners and shadows offer protection for foraging mice, while south and west-facing walls buffer against cold temperatures in winter months. Higher captures near rodent-proof doors and poured concrete walls could be a response to the need for cover or escape routes in areas with no entry or exit points. In other words, rodents foraging near these pest-proof structures have no other options for cover and might enter traps in response to disturbance. Support for this hypothesis comes from related results of decreased monthly capture associated with devices near a loading dock door with the leveler not pest-proof and near a corrugated wall with insulation. In these settings, rodents would have sufficient openings to hide or escape while foraging, and therefore may not enter multi-catch curiosity traps. Taken together, these results justify the use of pest exclusion to seal openings as a method to not only prevent rodent entry, but also enhance rodent management. And finally, devices near a warm mechanical room were associated with decreased rodent capture, perhaps because devices were not placed close enough to the warm elements of these spaces, but rather located along the mechanical room's interior perimeter walls. Rodenticide consumption data was available from 4 sites, representing 2,769 observations on 73 bait stations. No feeding accounted for 36.8% of observations, with minimal feeding of one corner removed observed 19.4% of the time. Monthly bait consumption was higher for stations located on the west side of the building and near unmaintained, dense vegetation. As with interior areas, the west side of the building is associated with warmth during winter months, while dense vegetation provides cover for rodents to forage. Our results demonstrate that certain ecological and structural features of a facility are associated with higher trap capture on the interior and increased bait consumption on the exterior. Considering that, on average, fewer than half of all interior multi-catch devices caught mice, it seems that interval device spacing does not maximize rodent management at food distribution centers. So where do we go from here? We propose a paradigm shift toward assessment-based placement of devices, which can offer time and cost savings by reducing the number of traps deployed inside and out of facilities, can enhance food safety by improving program efficacy, and can reduce environmental waste from discarded rodenticide blocks. In addition, dynamic programs that rely on inspection and interpretation of evidence can reduce trap fatigue, a phenomenon where device captures decrease over time if traps remain stationary, especially for stable rodent populations. Assessment-based programs can also reduce technician fatigue, where service professionals become trap checkers that open, clean, and replace bait or glue boards without assessing the rodent problem or developing management approaches specific to that location. And finally, assessment-based placement of devices facilitates compliance with the Food Safety Modernization Act of 2011, and specifically the Preventive Controls for Human Food Rule, which calls for proactive programs. We'd like to thank our sponsors for this work, which included funding from the National Institute of Food and Agriculture and collaborating pest management professionals from RK Environmental and Able Pest Control. Thank you.